All right, so we are recording, and this is Paideia 301 Class 12, and we're going to be continuing our coverage of for loops with a focus on for loops with dollar order. And we are going to review some homeworks first, and then we are going to work and continuing our lesson with for loops. All right. So the first one I want to take a look at is Tom's routine, and so this is pretty much what we expect. I asked you last week for the homework to do a menu, and this is how he did the menu. And there's something I forgot to tell you guys, and I'm so sorry. I was wondering why did you all do that, which is quit if exit equal 1, and the reason turns out to be is because I did it. So you do not need to put quit if exit equals 1 in mumps. If exit is 0 or exit is the empty string, which is the same as 0, because if you put a plus sign in front of it, it becomes a 0. You could just say quit if exit. And so we could actually change that and just say quit if exit. So that's one improvement that you guys could all make to your routines, and it's actually pretty important because in mumps there are some languages that require you to explicitly say what are you how are you comparing your variable. But mumps is like the C language in that regard, in that basically any non-zero variable is by default true. So we don't have to do this. So here's a for loop. These are several write statements, and that's nothing hard about these ones. And then we read in our choice, and depending on what we enter, we execute different parts of the routine. So let's actually give it a try and see whether it will work or not. Oh, by the way, just a few corrections for Thomas. If you run your routine through xindex, it's going to complain that your first line is wrong. The way you do it is you put your organization / your initials, and then a dash, and then you type in the description, and then semicolon, and you type in the date. Now this format is dictated by the SAC, so it's actually not my own invention. It's the SAC, and it's hard coded inside of xindex. Now, xindex is going to also complain about the second line, but we're not going to worry about that right now. Okay. So I'm going to test the quit first thing. So you notice what just happened? I can't quit. So we'll need to debug the program. So one way I showed you is to press Control-C and type Z-show to look at the stack. And we are at W10 plus 8. So write $text of this routine. And it says read your choice, and my choice is C. So if we look at the routine, W10 plus 8 to W10 plus 13. So it says that if the parts that we're interested in, it says that if my choice is, it's going to read my choice, and if my choice is an up caret, like over here, should go to exit. And we'll see why that doesn't work. So let's try it. So we're going to Z step, and if you remember from Z stepping, we have to set this first. So Z step into, and I'm entering my choice as an up caret. All right, so now it's gonna do exit. So let's go, it's supposed to go to exit. Let's see if it does. It does not. So I have to figure out why. Why doesn't that work? So write C. So oh, Tom, this is a good one. I like that. Okay, we have an instructable moment here. We really have an instructable moment. So the we figured out from stepping through the program that our problem is actually has to do with that this code does not run correctly. So what we have to do is just take it on the command line and write it out. So and remember, our C is still on up caret, so let's write this. Okay, that sounds good. Now, why didn't it work, though? If C equals... Oh, I know. Okay. Write C. Write C equals... It's a 0. Anybody getting enlightenment yet? This condition is always false. So the question is, how are we supposed to write it? So the way you're supposed to write it is if C equals Q or C equals little q or C equals up caret. All right. And what's C? C is an up caret. So that's the way we're going to fix this routine first. So that's the first thing we have to do. So let me just copy this into my clipboard so I won't have to type it again. Here we go. Okay. And I believe we have the same problems with all of them, if you look up above, because it's the same syntax. And I think I get an idea where Tom is coming from. He's trying to do it in the way another language might do it. But you actually have to put the condition for the variable for every time. None worked. Okay, yes. So I'll show you another way to do it, Tom. Ready? Ready? Okay. You could do this. This is easier to type than than what I typed at the bottom. It is tricky, but you see it in VISTA MUMPS code. That's why you have to know about it. So, who wants to explain to me what's it doing? Anybody? Yep, that's correct. So that's correct. It contains. Now, here's the trick. Most of the time when we are programming, even in Excel, we usually say, does a variable contain a string? Here we reversed it. We're saying, does a string contain a variable? It has the same effect as if you typed in your variable is one letter long, and if C is little a or big A, it's going to match the first condition. If C is little l, capital L, it's going to match the second condition, and so on. Now, of course, you have to make sure that C is one character long. So, oddly enough, little a, capital A would work. Little l, capital L would work together. But, does it matter that much to us? Nah, not that much. Because if the user types anything else, it's not going to work. So let's give it a shot now that we fixed all of these. Ah, okay. And remember, okay, quiz time, quiz time. What do I do when this happens? Okay, very good, Linda. What? But Linda, you're missing one step. Okay. You got the Z goto right. Z goto pops the stack. Z link, exactly. So if I type Z link again, it's gonna tell you I can't do it. Sorry. And if I want to find out why, I type Z show and it shows me the stack. And the routine is somewhere in the stack, and you could see it's right at the bottom here. So I'm just gonna do Z go to. Now if I show the stack, it's empty. I go ahead and Z link now, and it's working now. Now it should work. All right, let's try the quit. Oh, look at this. Oh, another bug. Let's find out where it is. Okay, he says I tried C contains A and it didn't work. Yes, it's not gonna work. It has to be A, capital A, little a contains C, Tom. Okay, so actually it sort of behaved correctly, then something else happened. So again, Control C. We're gonna use Z show so that we could find out where we are. We're at way +1, the line immediately after the for loop. So who wants to tell me what they think the problem is? Very good, Tony. Actually, it's simpler than that. You're making it more complex. It's just a quit is missing. Okay, well, I'm gonna explain it. So when we hit the do exit, it jumps down to the label called exit, and let's jump to exit. And here's exit, and it sets the exit variable to equal to 1. So let's go back to the top. So it's gonna hit exit, and then since there's nothing to execute furthermore in the do block, it goes down here and says, oh, I'm done, let me go up, Okay, so it's gonna execute the next statement after the do, and it is quit if exit. But what happens when this line executes? Tom, thank you very much for making this example. I couldn't have done it better. It's really good. I mentioned it last class. Why doesn't this quit make us quit from the routine? After all, it is a quit. It should make us quit the routine. Why is it not letting us quit the routine? Exactly. A quit on a for line always makes you quit the for loop, and it does not make you quit anything else. Now, by contrast, if you typed if something, do something, quit if exit, guess what this quit is gonna do? This is important to understand because it's something really tricky in mumps. Unfortunately, is not a feature I would like to have. But the quit on a for loop is very special. It's different from all the other quits. The quit on the for loop only makes you quit the for loop. If you have the quit anywhere else, it means quit from that do level. Or if your routine is your first do level, then it's going to quit out of the routine. So we're not going to worry about this. And let's go ahead and delete this line. Oops, wrong button. F1D. Here we go. So what we have to do is recognizing that quit just quits the for loop. And when we quit the for loop, it's going to go to the next line, which is this semicolon over here. So what we have to do is we have to, oops, wrong button. Sorry, guys. What we have to do is we have to type quit down here. And we could type end of WTIN. Now, one other thing I would like to point out, and that is VISTA requires you to put at least a semicolon after that is X index, specifically X index. X index is the lint style checker for your MUMPS style. Make sure that your MUMPS is conformant with VISTA styles. And this semicolon is intended so that you could actually put a comment on what this does. So let's just say here, menu system. All right. Again, same problems. You go to the link. Let's run it. Let's see if we can quit this time. Yes, we can quit this time. Okay. Oh, I pressed a question mark. Okay. Oh, it's not asking me for the next pumpkin. Well. Oh, list doesn't work. Print. Oh, print gets me out. So I think Tom has an updated version. But let's just take a look at a few things quickly. So print does not work, and print falls through to exit. That explains why when we execute print, it runs here and it goes down and quits. So we're not gonna worry about fixing that. We're gonna talk with Tom and try to figure out where fix wait and list. So let's start with this one. So this is correct as far as it goes. Read pumpkin weight, but here's the question. Here's the thing. You're always storing it in the same variable. Now that could be okay if you don't plan to store it elsewhere. Now the big question is list down here thinks that you're storing it in Y, I think, in Y sub EX X1 sub EN, and EN looks like it's the pumpkin number. So EN is the pumpkin number, and X1 is the pumpkin weight. So the first thing I would do to with this routine is I find the variable names confusing. So I would rather have each variable be sort of approximately what it means. So instead of x1, let me just make sure that we're not using the variables elsewhere. We're only initializing them at the top, so I won't worry about it. So the pumpkin's weight, we're gonna make it I'm gonna put a comment saying pumpkin weight so I know what I'm talking about. And then instead of en, again, that does not really tell me. We could call it counter or something like that. I'm gonna call it pumpkin number. Pumpkin number plus 1. So pumpkin number is not. It's actually gonna crash here, but I'm gonna wait for it to crash so that I'll show you how we could fix it. So the next line is if x is numeric, do the menu system again. Okay. This one actually requires a deep explanation, and for that reason, I'm going to restore it. Because I need to tell you guys why you should not do that. Oh, come on. Yes, actually, didn't I tell you? I forgot that I just told you that. Isn't that interesting? So, PumNum needs to be. You probably have all dealt with this error if you've actually followed along and did some of the homeworks. And essentially, if you don't initialize a variable, you get this. You get undefined local variable. So, and the way that you guys have dealt with that is to initialize them at the top of the routine, which is a good idea. But there's another way to do it. Now I could actually show you how to do it. It's time to teach you about $get. We covered $get briefly, but it's good to cover it again today. $get, it tells mumps, okay, if this variable is defined, get me its real value. If it's not defined, just get me the empty string. And that's exactly what will happen. So empty string, what's empty string plus 1? Any guesses? All right, Linda says 1. Alice says 1. Very good. So empty string plus 1 is going to get us 1. So this makes us avoid having to initialize the variable again. So back to trying to run the routine and show you what I wanted to show you. Okay, so it goes back to the menu. I want to show you something now. All right, I'm going to press Control C here. I'm going to show you the stack. Who notices what's wrong over here with the stack? So Linda says, okay, go ahead, Linda. That's correct. That's correct. So what Tom's program is doing, it's actually invoking the menu again via do, and it's adding levels to the stack. Now, let me. We talked about the stack and how a difficult concept it is. I've been reading another programming book, programming in C++ actually, and they had a good analogy there. The stack is like a set of plates. You actually put the plates on top of each other, and when you need to take a plate from the stack of plates, you actually need to take the plate at the top. Now, here's the problem with the stack. MUMPS does not have an infinite stack level, and most other languages don't actually either. But by the standard, I believe MUMPS is supposed to have 128, but I believe GTM has about 1024. The point is, you when you're writing programs that keep calling each other, you keep stacking up, and depending on how much data you have, that could eventually crash your system. So it's generally not a good idea to do that. It will work, as you know, we can probably attest, because once we hit the quit, it's supposed to work. Actually, I want to know whether it's gonna work. Let's see if I do this. Oh, it did work. Okay. So the thing about the quit here is that the quit managed to pop off all our levels of the stack. And the way it did that is actually somewhat complex. I want to see if we could follow it through. So let's start from this point over here in the program. When we do way over here, it's gonna go back to up top over here, and it's gonna run this. So the big question is, let's pretend we're gonna do it again. So we're gonna open another level of the stack. So here's way, and then here we're going down here, and we're gonna go here and go back up. So what happens when I hit exit? So I go to this exit, whose only function is to set a variable equal to 1, the exit variable, and it quits this exit. But remember, this is not the last level of the stack. This one makes it hard. When this quits, it actually goes back down to this level and then says, oh, okay, I'm done. And then it's not gonna execute else. Then it's gonna hit this quit. And after this one quits, it's gonna go back to the next level, and it's gonna be here, and it heads down and hits this quit. Are you guys confused yet or not? I find the fact that the way it actually works right now pretty confusing. But I just want to tell you there is logic to how all of the levels of the stack actually got blown up just by doing the exit. And the fact is, it eventually all of them ended up around here and went back down to this quit. Eventually, we hit the last quit and we quit out of the routine. Do you guys want to see a demonstration of that by stepping? Yes or no? Okay. So let's do it again. All right. So I want to show you where we are right now. Okay, so I'm going to do z step into, and I'm going to put an up caret in response to the read statement. And of course, we know that this is not going to run, this is not going to run, but this one will run. It's going to do exit, and it's going to write thank you, goodbye. Then we set exit equal to 1. And we quit. Now remember, GTM is not going to show you the for loop line. I just want to let you know that that one is going to get invoked, and we're going to hit quit exit. And when we quit if exit, and when we quit the for loop, we hit the quit at the end of W10, which I added just a few minutes earlier. So let's find out. Let's see where we are right now. Z write or Z show? Okay, here we are. I'll show you. We just have pumpkin number 7 and pumpkin weights. Remember, we're storing x1. We're not putting them in an array right now. Okay. Let's look at our stack. So we're going to hit a quit, so we're supposed to blow off this level of the stack up at the top, the topmost plate. So, good. Let's look at the stack now. We should be at way plus 4 at the top. And we indeed are. And the level of the stack at the very top got blown away. Let me just make sure you guys see that. So here's way plus 4. And over here it was way plus 3 and then W10 plus 13. So it's not going to execute. Then we're going to hit the quit. And that's going to remove that plate from the stack. All right. Now remember, W10 is going to quit as well because exit is 1. So it's in let me show you that line. No, that's not the line I wanted. Well, it was another line. Oh yeah, here. It's W10 plus 9. I have it. Okay, this is the line we were at, actually. Remember, you see do way and then quit. So this quits inside from the dot level. It goes back up to the top line of the for loop, and the top line of the for loop says quit if exit is 1, and exit is 1. Therefore, it goes back down to the quit down here. And we go back down to our other part of the routine. And we hit this quit. Let's see. And that got taken off. Now we have another quit to encounter. and we went back to this line again. Let's look at this quit. So here we go. Okay, so we actually quit all the way. Now, I just want to say to Tom, the fact that this worked was actually an accident for you, because it wasn't necessarily going to work. You saw how complex the program has become when you started calling do's altogether. But, however, I have to thank you very profusely. You've done me a great service, because I really needed to teach this, and I would not have known how to teach it without me showing up an example. So, let's continue. Okay, so let's go back down here and see if we could fix this and make sure it does not call each other all the time. So the first thing I want to do is I actually want to make a for loop for entering pumpkin weights. So we're gonna change this to, as we said, pumpkin weight. I'm gonna make a for with 2 spaces. It's gonna read the pumpkin weight. And I'm going to have, oh, of course, I have to remove the comment. I'm going to have a very simple quit condition. That quit condition, when you're doing for loops, you become very artistic with quit conditions. This quit condition says if the pumpkin weight is not numeric. That's all it says. Does that make sense? This is a bit hard. If x is ABC, let's try it. Okay, let's make x ABC. So write plus ABC. You see it's 0. So what's not ABC? It's 1. So quit if not x. And guys, I'm serious. You're gonna have to know this to read MUMPS code. So I'm teaching you some stuff today that you commonly see a lot, and I would call them MUMPS idioms, because they show up in code, but they really don't make any sense when you first read them. This says quit if x doesn't start with a number. Non-numeric strings have a truth value of 0. That's correct, Linda. That's exactly right. More accurately, they have a numeric value of 0, because MUMPS always switches data types in a single order. It switches from string to number to Boolean. It does not switch from string to Boolean all at once. That's a fantastic question, Rob. Is it the same? It's actually better, because not plus x is exactly the same thing as not x. It's exactly the same. Why? Because MUMPS always follows a single chain in conversion. It will always convert your string to a number first, then it's going to convert it to a Boolean value. When you do a Boolean, it's going to do the numeric conversion behind closed doors, so to speak, and then do the Boolean conversion. Make sense? The plus makes it clear. I would agree, but you know, eventually, when you've looked at if you looked at enough gobbledygook long enough in your life, you know, you figure out that quit if not x means quit if your x does not start with a number. Now notice I said that quit if x does not start with a number, which means because if you write plus 78 ABC it becomes 78. And not of 78 is, who wants to take a guess? It's 0. So there's another expression to quit for loops that has to do with it not being numeric. And this one is more accurate, but you don't see it as often. Quit if plus x is not equal to x. This is quit if x isn't a number. Now, yes, it's actually more accurate, but no, you don't see it in Vista code that often. Why is that? Because it's pretty rare in Vista where we actually have an index and fileman whose name consists of contains a number. In fact, I believe it's not allowed in fileman for your index to start with a number. It has to start with a letter. So that's why this is not an issue inside of fileman, and therefore most of the time when you see people looping inside of Vista, you're going to see this. You're going to see this. All right, so let's read our pumpkin weight, and we're going to quit if not x. Now we're going to have to tell the user about that. So write enter weights for each pumpkin. Type up caret or q to quit. Now, of course, we're just telling the user that, but we're not really checking for an up caret or a q. So that could be a problem, but you know what? We're going to stick with it for now. And one other improvement I would like to make is I would actually like to show the pumpkin number for each pumpkin. So ideally, I would like this line to be up with the for loop. Now the for loop is actually getting complex now. So let me write this line over here. Set pum num equal $get of pum num plus 1. And then I would say read pumpkin underscore number underscore pum num underscore weight. All right, the line is getting too long, so it doesn't look it does not look like it's a good fit right now. So what am I gonna do with this? What I'm gonna do is I'm gonna create a do block. So I'm gonna say for. Oops, that's right. I remember that's VPE does that. Do you remember how to split a line in VPE? Escape B. Oh, thank you, Linda. Well, I did not know that. So for do, and we're gonna still put the quit condition but we're gonna split this to escape B, escape B. Very good. Now we're gonna put the condition up here. Quit if. Now we're not reading X, by the way, so this is wrong. So wait, wait, and of course I forgot my dots. Here they are. Ah, wrong. Here we go. This is correct now. And we could delete this one. Now we already did this check where you see Tom checked if it's numeric. Now we could just say if it's not, we'll just say if it's not numeric, we're gonna quit. And in the for loop at top, if we quit here, we might also be able to quit from the for loop. So we're gonna delete this line. No, wrong button. And we're gonna ignore error checking for now. All right, now we need to store our data in an array. Now, Tom stored it in Y, so let's actually go ahead and store it in Y. It's okay. So set Y sub pumpkin weight, comma, pumpkin number, which is pumpkin number equals empty string. And to make our life easier for debugging, I'm just going to put a zeroite Y over here. And I'm going to remove the zeroite after I'm done. Usually when I'm programming, just so I could see the zeroites, I surround them by little, let's just say that this is debugging code. So we want to make sure that Y is empty at the top. So I'm going to go to make sure I kill Y at the top. Okay, I made a boo-boo. Let's see, read pumpkin number underscore. Maybe read does not take underscores. I never thought of that. Okay, he says read does not take underscores. Well, thank you for letting me know now. We're just gonna put commas. It's gonna do the same thing. So let's enter pumpkin weights. I forgot to put a new line, so that's okay. Enter pumpkin number? Oh, I know what I did. I'm so bad. It's the read, and read has a variable. I need to do a write. These things are so obvious after you've done them. Oh yeah, put in my bank, thank you. Oh, by the way, I've noticed that I believe it was Manoj's homework. You always did this when I looked at your homework. You always did this to do 2 new lines. You don't have to. You could just remove the comma. This is the same thing. Now, why isn't my double escape working? Oh, I'm in Vim? That's so funny. You know, old habits die hard. Here we go. This is better. 33, 22, 44, 11, up caret. All right. So what do you think? This looks good, right? All right. So, the last thing we're gonna do in this routine, and it's almost took an hour now, but it's an hour well spent. We're gonna do the listing now. So we're gonna remove the debug, or sometimes in my code I just commented out. So okay. So all right. So list all the pumpkins, and so you can. We are listing. I'm not sure what this line is for. I don't have any clue. Tom, any ideas? What's this line supposed to do? What's x1 and en at this point? X1 used to be the pumpkin weight and en used to be the pumpkin number, but we already have an array and we don't want to modify it. So I guess I'm going to take this out. All right. And since you are setting the variable weight inside of the for loop when you say for weight equals 0 colon 0, you don't need to set weight equal to the empty string. However, oh, by the way, he moved on to the extra credit portion of the class. Maybe we should stop here. I just realized that we're doing dollar order and this is what we're supposed to cover today. Okay, we're going to stop here then. I'm going to go ahead and save it. And we're going to stop here for examining Tom's routine. Tom, thank you very, very much. You know, I don't know how I realize how much you helped me teach. Okay, Manoj is typing something. I'm waiting. Uh, Actually, Manoj, no thanks. That's okay. I can't do it today because we're running out of time. I already read your homework and you did a decent job. And trust me, if we got started with Tony's homework, we're never gonna get done. So, so let's talk about yikes. So, let's talk about. We're gonna talk about dollar order, and so let me remind you of how dollar order worked. So, we do have a file in Vista called the title file. Okay, here we go. It's pretty cool. So I'm gonna browse and I'm gonna show you. So this is a simple global array, and this is typical. It's a very tiny FileMan file. Actually, it's probably one of the smallest ones you'll ever see. It just has 9 entries. And I just want to show you how we're going to traverse it using dollar order. So this is important. But before I show you how to do it with a FileMan file, we're going to do it with a very simple array. So we're going to kill x. We're going to set x sub 1 equal hello. Set x sub 2 equal bye. And set x sub 3 equal. All right, you're going to have to forgive me. I'm a programmer. I cannot come up with any decent examples. Not my strong suit. So let's do a quick review of what dollar order does. So If I write $order of x sub empty string, I get 1. If I do $order of x sub 1, I get 2. If I do $order of x sub 2, I get 3. If I do $order of x sub 3, I'm getting the empty string. And I can prove that by saying, is it equal to the empty string? And the answer is yes. So far, so good. So most typically in MUMPS, and you're gonna write this line a million times. Trust me, in my career in MUMPS, I've been writing this line every single time, every day, or even multiple times per day. And that line is to order through an array. So let's see how you could order through an array. So there are several ways to do it. So we usually use the variable I to do iterations just because of convention, but you could use any variable you want. Let's use the variable count. So we usually set count to equal to the empty string. Then we do for 2 spaces, set count equal to $order of x sub count. Notice the recursion. Quit if not count. 2 spaces after the quit, write count new line. Okay. I'm stopping here. Any questions about this? Did it make any sense? Actually, I want to simplify it for you because I think this might be a bit confusing. Remember, we start and end with the empty string. So I could just do this. Quit if count is equal to the empty string. That should be easier to understand. So you're going to write lines like this over and over and over in MUMPS, over and over and over again. So you better get comfortable with them. So this is a very simple array. Let's try doing it on the fileman file. Now, the fileman entry in a file is called an IEN, or an internal entry number. So let me write DIC sub 3.1, comma 1, and going forward. So let me go here. You see this middle subscript in here? 1, 2, 3, 4, 5, and so on. But not including these, because these actually don't belong to the regular file. These are called IENs, or internal record numbers. If you're on the patient file, it's called the DFN. If you're on the user file or the new person file, it's called DUZ. And some programmers in the mid 90s stopped calling them IENs and called them IFNs. They're all the same thing. I'll write this down because I see Linda's taking notes. So IEN is internal entry number. DFN, same, but for file 2 or 9,000,001, which is patient file. I hope I have 9,000,001 correct here. Yeah, I do. DUZ, also the same, but for file 200. IFN, another name for IEN. Now, when I program, I typically just use the name IEN. I do not use any of the other names unless unless I'm dealing with other files. But there are restrictions on actually using DFN and DUZ according to the SAC. Actually, specifically DUZ you cannot change if you're running VISTA code because the kernel sets the DUZ. So the way I'm going to do this is as follows. I'm going to say set IEN equal to empty string for set IEN equal $order of upcaret DIC 3.1 comma IEN quit if not IEN write IEN new line. And I screwed up. Now where did I screw up? Oh, I made the mistake that I should have told you about. You know, you should sometimes never follow what Sam says. The first IEN is 0, and not 0 is 1, so it's going to quit out of here. So that's not going to help. So we actually have to use this format. So that gives us these entries, which is 1 through 9 plus the 2%. Now, the percents and the B are not really part of the files. So actually, it did this essentially. That's not going to work on GTM. That works on cache. So never mind. Okay, just take it from me that there's a B at the bottom. No, don't take it from me. I'm going to show it to you. Okay, you see the B after the %D? So we actually have a couple of problems in this logic. And let's find out what these problems are. Who wants to tell me what the problems are in the logic? Okay, Tony's offering. Okay, Rob's offering. Okay, that's correct. That's correct. So Tony and Rob both pointed to the problem of fileman indexes, which come after the entries, and we don't want those indexes. But we also don't want the 0, because the fileman internal entry number of 0 is not valid. Let me tell you why. You might hear, you know, Vista geeks if you hang out in halls and hide out. You might hear them talk about the 0 node of a file. This is the 0 node of a file. A 0 node of a file contains file metadata, and in here it says the file name, the file number. There are. Come to the Vista community meetings. That's where they seem to come all the time. And the last two entries are which entry was last edited and what's the greatest entry in the file. And so you never want to get the 0 node. So by convention, when you order through a fileman file, you do the following. You do not start from the empty string because what follows the empty string is a 0. Let me prove that to you. Write $order of DIC sub 3.1 comma empty string, and that's a 0. But look what would happen if I start with a 0. Now we're talking. So the first change I'm going to make is instead of starting from empty string, I'm going to start from 0. And let's see what we're going to get. So I think we've made a little bit of an improvement. We now don't have 0, but we still have the problem of non-numeric subscripts. So the question is, how are we going to prevent the non-numeric subscripts from showing up? Well, that's actually pretty simple because I already covered it. We're going to remove, yep, exactly. We're going to say if not IEN. And now we finally just print the numbers. Okay, so far so good. But there's even a simpler way to do this. Not much simpler, but a simplification. So, one problem is that you have to set the IEN in advance outside of the for loop. And if you forget to do that, let me show you what happens. Let's kill. And now, by the way, kill by itself deletes everything in the symbol table, so IEN is not defined. I've totally forgot to tell you guys that, but now you know. So if I forget to define IEN, I get this problem. So there is actually a better way to do this. And remember I told you about infinite loops and how you could use 0 step 0 for an infinite loop? Well, guess what? If I do 0 step 0 here, I'm going to loop through the file and I'm going to start with 0. I don't have to set my IEN in advance. Okay, what's the upshot of all of this? That's my big question. I've showed you various variations of doing the same thing. Essentially, if you want to traverse a FileMan file, this is how you have to do it. Just exactly like this. Because it's not going to work for other kinds of arrays. Why not? Because other arrays have 0 nodes which you might care about. So let me back up a little bit and tell you about a generalization. So general form of $order with for loops. Most of the time, if you're traversing an array like the pumpkin weight array, which we had in our homework, the way you're gonna traverse the pumpkin weight array is pretty simple. Actually, I'll show you how first, and let's make one. So what you're gonna do is you're gonna set I equal empty string, and then you're gonna do for with 2 spaces set I equal $order array sub I, quit if I equals the empty string, and then do etc. So the rest is up to you, whatever you want to do. So this is the general form of for loops, which traverses from the very beginning to the end. Let's try it. So set weight of pumpkin 3 equal, actually I don't remember how we arranged them. We said 30 is for 3 and weight of 40 is for 1 and weight of 22 is for 2. Now if we zero-write weight, we see this. So let's apply the formula we have at the top in order to traverse this array. So set I equal empty for 2 spaces, set I equal $order of weight sub I, quit if I equals empty string, write weight. Okay, now actually We don't know. Let's just write I. Okay, simple enough. So that's the general form of dollar order. But if you apply this general form with fileman files, it does not give you the results that you want. I'm gonna do this again. Okay, what's wrong with this picture? Two things. Zero nodes. We don't want the zero node because it's not a real record. We also don't want the cross references, which come after we finish internal entry numbers. So the way we traverse fileman files is as follows. So fileman general form. We say for I equals 0:0, set I equal dollar order of DIC. Yeah, that's right. Sorry, I thought I forgot something. 3.1 comma I. Quit if not I, because we don't want the subscripts. And we start from 0 this time, so we won't get 0. And now we get the right results. So I want to make sure everybody understands this, because this is one of the most important concepts when you are developing for VISTA. Because you're going to be going through a ton of arrays, and you need to know exactly when to start and when to stop. Okay. Okay. Linda has a very good question. I'm going to cover it. Do cross-references always come at the end of the files? Alice, fantastic question. I'll answer Alice's question first, because it's very easy to answer, actually. MUMPS has something called MUMPS style collation, and it's pretty much the default unless you specify otherwise. And it's the one that you expect to have in VISTA. So remember our wait array? So let's say we make a cross reference called B on the wait. All right. So if we set wait sub B comma pumpkin2 equals 22, set wait of B comma 3 equals 30, set wait of B comma 1 equal 40. 0.8 wait. Okay, so this is a very simple example, but what this example shows you is that whenever MUMPS auto sorts an array, it puts numbers first, then letters. So by default, and because FileMan was developed for MUMPS, FileMan by design uses the non-numeric subscripts for cross-references. So cross-references always come at the end of a file. Does that answer your question? Okay, good. So now Linda, let's talk about for Linda. Okay, I'm gonna go back to this loop again, and again now we have the B here, and we don't want the B. So we're gonna change this to tell it to stop looping. Oops, this is still correct. To stop looping when we are done with numbers. So quit if not I. So now this is correct. Now Linda's question is, okay, we only have, we loop to the first level. Now I want to loop to the second level. How do I do that? Well, you do that by writing concentric for loops. So you write a for loop inside a for loop. So let's do it. So we're gonna do the instead of quitting here, instead of writing I here, we're gonna do another. We're gonna say set j equal to the empty string, because what follows I is j. We're gonna do one extra space here when we don't need it. So for j equal dollar order of weight sub I comma j. Quit if not j. Write I comma j comma, let's put a space between them, comma new line. All right, I hope I wrote this correctly, and I did. Here you go. So now, of course, when you're writing in a routine, you do not have to do this. You could actually do them on separate lines and put a do after each one. I'm going to show you that in a moment. Oh, why no set on the second loop? Did I not do a set on the second loop? Oh, you're right. I made a boo-boo. You're right. You're right. I honestly don't have a freaking clue why it worked. Oh, it worked because for we were lucky because we only had one subscript. We were lucky because we only had J as one subscript. Now J doesn't work. I need to find out why. Oh, come on. 0.8 weight. Oh, it deleted the stuff that we had. Okay, that's fine. We're gonna do it again, so hold tight. What's my phone? I can write J comma I, of course, Tom. No, what am I doing? Here. So kill weight, we're gonna set weight of 30 comma 2 equal empty string, set weight of 40 comma 4 comma 3 equal the empty string, and set weight of 50 comma 1 equal to the empty string. All right, so let's empty line, wrong here. So we're gonna do, remember, so rather than setting I and J at the for loop, I'm gonna set them here. So set I and J equal to the empty string. For set I equal dollar order of weight sub I, quit if not I, and that means it's not gonna get any numeric subscripts, excuse me, non-numeric, even though we have none of them. Okay, good enough. Then quit has to have two spaces and then do. Then we do this. For set j equal dollar order of weight comma I comma j, two parents quit if not j, do. Two dots. Write I space j. Actually, let's follow what Tom suggested. J comma I new line. And to be a good citizen, I have to put a quit at the end. So let's print kband 4 and do upcard kband 4. Here you go. All right. Linda has a question. Oh, okay. You'll need to have some more code to have them in order by J. Yeah, that's correct. Now, I haven't covered exactly how you index data in FileMan, and I might need to cover that, but we only have 8 minutes left. Yeah, I'm gonna stick. I think I'm gonna pass on that for today. Okay, why am I demoing a for loop inside a for loop again? Okay, let's take a look at the routine. So, Alice, the first I just goes through the first subscript, which is 30, 40, 50. The second subscript, which is J, go for each subscript of I, it actually moves through and prints the J for each one. Does that make sense? Okay. Let me actually make this a bit more interesting. You know, we could have a couple of pumpkins with the same weight. So let's say that pumpkin 4 also weighs 40 pounds. So let me run the routine. Here you go. You could see that pumpkin 1 is the heaviest. Pumpkin 2, pumpkin 4, pumpkin 4 and pumpkin 3 are equal, and pumpkin 2 is the lightest. Another variation. Remember, guys, I told you we could reverse the way dollar order goes through the subscripts by adding -1 as a second argument. Let's try that. So now it printed the heaviest pumpkin first, and then it printed all the other pumpkins. Okay, Linda's quizzical. No, you're okay? All right. Any questions about this so far? Okay, good. All right, there's one more form of the for loop that I forgot to discuss last week, and I should have discussed it last week, so sorry about that. But, you know, this is what happens when you teach it from your head. Let me try this. So for loop has another form. So this works like this. So for x equal a, b, c, 1, 2, 3, write x new line. So you could actually remember we had a for loop that does we had for loops that had counters and they use dollar order and so on. This is yet another form of the for loop. It's not as commonly used in Vista because most of the time in Vista we want to iterate through arrays, but in this case you guys just go through a value, or a set of values. So it's not really commonly used, and it's just there. It's just there just in case you need it. So I've actually just used it because I'm sort of writing a pharmacy interface, and I have a local array where I keep all the data. All right, I'll Z-write X again. X is at the last value. Uh-huh. So, um, my use case for this was that I had indexes on the value. So remember, if we had zeroth weight, we had something like this. So let's say I wanted to delete the data. So but I knew what the data was, so I could say for x equal 30, 40, 50, kill weight sub kill weight sub x. Actually, let's just do 30 and 40. And zeroth weight. Here you go. That's one use case for it. So it's not as commonly used, but you might find a use for it that might suit you in MUMPS. Okay, so homework for this week. You guys already know what it is, and a lot of you have actually. Yes, exactly. Thank you, Alice. I use it to erase specific nodes. I'm going to show you another example, but just let me cover the homework quickly. The homework is same pumpkin routine. Now, make sure that you can store and print data for as many pumpkins that the user wants to enter. Print in reverse order. So heaviest pumpkin first. So a lot of you have actually done this homework already. I just want this message is specifically for Tony. I want you to fix your for loop at the bottom because it's wild. You you have to start. This is the thing is you did dollar order based on the beginning and ending value, but you could just do it based on the empty string and the empty string. So you don't have to do a lot of the extra code that you actually did. But I have to say you've done a wonderful job with all that extra code because that must have been pretty hard to debug. Okay. For Alice's benefit, XML PRS 0. Nope. That doesn't look like the right routine. MXML DON. This is the VISTA parser, and here it is. That's the routine I want. MXML PRSC. So I'm gonna show you lots of for loops here, but there's a specific one I want to show you. Okay, let me see if I could highlight this. Nope, I don't have that capability, damn it. Okay, Control A, escape. Okay, do you guys see this? I want you to look at the for loop over here. So this is a very tricky line. I'm not sure who wrote this, but the way that this works is, you give it, this tries to load a document from the file system, an XML document from the file system, and the way MUMPS does not know what operating system it's on, so your path could contain backslashes like in Windows, or it could contain forward slashes like in uh, Linux or Macs, or it could contain the last two characters, which is the what is that? Left bracket and a colon, which you'll find on a VMS system. So it does not know which one it is. So it checks to see every one using a for loop, and it quits when the first one is true, which means that the document contains that character. So it checks to see if the path contains X. Did I explain it well, or is it confusing still? Oops, I don't know why. I don't know why I can't browse here. Okay, another thing. Now that you've learned about for loops, I'm realizing that you guys could read most of this routine now. I'm a bit surprised, but you guys could read most of it from what we learned. We're gonna discuss new, hopefully, I'm thinking maybe next week. And we've talked about dollar $text briefly, but dollar $text gives you an identifier. Here's dollar $character, which we talked about a long time ago. Qt equals to an empty string. And look, remember you could set all of these all at once to 0 using the syntax. Look, you could set these to the syntax. We just learned about dollar $get today. We learned about here's another way to do it.
Can you explain that? I mean, that doesn't look like it's simply saying Qt equals empty string.
Q.
Qt equals two quotes.
Oh, that's right. I'm sorry. Did I say empty string? No, Qt is a quote. Qt stands for quote, and it's just a quote character. And in order to get a quote character, you have to double up a quote. So, sorry. And we're gonna cover, this is an extrinsic function, which we're gonna cover hopefully next week or the week after. And we have a kill, and we know what a kill does in a global. And we have if dollar $length of dollar $text. Now we've used dollar $text to detect lines in a routine, but dollar $text to print out lines in a routine. But dollar $text also returns an empty string if the routine doesn't exist. So this way it's just using to check if a routine exists. Excuse me. And then here you have do with several commas, and we know what that means. And here's a for loop. And here's the quit condition. And it has to do all of these things. And here's a do, and here's a do with a post condition on the argument. And so on. So guess what, guys? MUMPS code is finally becoming intelligible to you. And this is a hard MUMPS routine. I mean, this is what you typically see. It's not that well commented, but you see some indirection. He's right. There is some indirection, and we have to cover indirection. That's still in the future. Oh, excuse me, guys. Sorry. So that's it for today's class, and I'll hope to see you next class. So type any questions if you type any questions in the Skype chat if you have any. Otherwise, we're gonna break right now. All right.